Solving matrix equations. That's the topic of this video. In this video, we're going to be looking at how do we find a particular matrix that's in an equation. The setup is going to be something like this. You'll be given some matrix A that will be provided to you. It'll be on the other side of the equal sign, have some matrix B, and our goal is to find out what do we have to multiply A by in order to produce this matrix B. That's going to be our basic setup. All right, and with that said, let's get right down to it. So this is very important. If AX equals B, then X equals A inverse times B. Very important. You better write that down. You're going to need it. What the saying is, in order to find our X, A, first of all, let me go back over here. This A has to have an inverse. Because if it doesn't have an inverse, I'm not going to be able to find this, which means I'm not going to be able to find my X. So being able to solve a matrix equation means your A has to have an inverse. If it doesn't have an inverse, you're just going to write no solution and move on. If it does have an inverse, then we're going to move to this formula. So let's write down some steps. Steps to solve matrix equation. Step 1, calculate A inverse if it exists. Right? It may not have an inverse. How do you know if it has an inverse or not? The determinant, right? If the determinant is 0, A has no inverse, and you'd be done. You'd write no solution for the equation and move on. If it does have a determinant that's not 0, then you have to find A inverse. Step 2, plug in A inverse and B into, this formula. All right, so X is already going to be by itself. That's pretty sweet, and we'll just have to do some matrix multiplication right quick to figure out what our X is. And finally, step 3 is to do basically what I just said, simplify. Specifically, we're going to have to use matrix multiplication, though. Okay, so there's our steps. Pause the video, write those down if I went too fast, and then let's move on to our first example. All right, so here's our setup. Here's our matrix A. On the right-hand side, we have our matrix B, and we're trying to find, what do I have to multiply this matrix by? That's what my capital X is. It's some unknown matrix that will then, in turn, produce the matrix that's on the right. So let's just follow our steps. Let's first find the inverse of A if it exists. All right, so step 1 is finding the inverse if it exists. Let's find the determinant of A first. And to find the determinant, I go corner to corner, upper left to lower right. 8 times -1 minus corner to corner, upper right times lower left, 5 times a -1. That's going to give me -8 plus 5, right? Which is in turn going to give me -3. Because the determinant is not 0, the inverse does exist. Now we need to find the inverse, but that's not too bad. We can handle that. So the inverse says, stick the determinant under 1. In our original A matrix, we switch 8 and -1. -1 is up in the left corner, upper left. 8 is now in the lower right. And then along where the 5 and the -1 are, they get to stay where they are, but they pick up the opposite sign, right? 5 now becomes and -1 becomes +1. And if we carefully push that -1/3 through, we're going to get a third, -1/3, 5/3, and -8/3. I'm moving kind of quickly because we've already had some practice calculating inverses and dealing with fractions, but if it's still a little fuzzy, you're not sure how I got that, please pause the video, call me over, I'll clarify. Now, step 2 is to plug this stuff and junk in to this formula, X equals A inverse times B, right? So, leave a little bit of room. I'm going to rewrite my inverse. Very important that the inverse is always on the left of b. You can't do it the other way around. You will not be able to do the multiplication if you try. A inverse has to be to the left of b. All right, carefully recopy. Carefully recopy. It would really suck to do all that work at the correct matrix, and then when you're solving for x, do something silly like leave off a minus or switch the -8 and the 3 in this fraction. In other words, let's take our time and write stuff down carefully so we get the right answer in the end, because after all, that is the ultimate goal. Now, what's my B matrix? My B matrix is -35, 1. Now what we're going to do is just multiply these two matrices together. Now I'm going to do this rather quickly. If I go too fast, I'm sorry. Call me over. I'll clarify, go a little bit slower, give you some one-on-one help. Very quickly, I'm going to write out what stuff I would multiply. I'm going to take the first row and I'm going to multiply it by the only column that's in the matrix. There's only one column in the second matrix. That's going to give me a third times -35 plus 5/3 times 1, right? I've exhausted all the columns in the second matrix. If I had more columns in the second matrix, I would continue to stick with my first row and do that process over and over and over again until I finished with all the columns in B. But B only has one column. I'm done. However, my inverse has 2 rows. I need to duplicate this process again. I need to redo it, but now I'm going to redo it using my second row first column. That's going to be -1/3 times -35 plus, what do we have? I put this in parentheses, -8/3 times 1. All right, now, let's simplify this. -35 times a third is simply -35/3. Plus 5/3 times 1 is 5/3. Now, the second row, a negative times a negative makes a positive. We're going to get 35/3 plus -8/3. And what does that boil down to? Well, -35 plus 5 is 30. All right, I'll do that over here. -30 now over 3. 35 plus a -8 is, what does that boil down to? Is that, I think, 27, right? 27 over 3. All right, and I'm able to add these numerators together because the denominators are the same. That is a requirement. Now, what does that reduce to, or simplify? 10, right? And 9. And we've accomplished our mission. We have found the matrix that we would need to multiply our A by in order to produce the matrix -35, 1. Okay, next example is going to be for you. Write it down, work it out, check your answer. Here we go. Next example coming your way. All right, check it out. The answer that I got for my capital X is 7, -9. That's what's inside my matrix X. I found the determinant to be -7. I calculated the inverse and got this pretty looking thing. I took that pretty looking thing and I plugged it into X equals A inverse B. Here's my A inverse. B is the 2914, and I simply did matrix multiplication to get 7, -9. Hopefully you got the same thing. If you didn't, see if you can find maybe where you slipped up. If you can't find your mistake, call me over. I'll be glad to help you. Let's move on to our last example. Okay, so we're going to do the same thing. Do our steps. Find the inverse. If the determinant is 0, this has no solution. You'd be done. You'd write no solution. You'd do a circle with a line through it, and then move on to the next problem. So please pause the video, try this problem out, and then check your answer. Well, check this out. A lot of interesting things happening in this problem. Let's go to the very end first, and then we'll backtrack to the beginning and run through it right quick. The matrix X that I got was 11, negative 5. How did I do that? I started off by finding my inverse if it exists. That existence hinges on what the determinant is. As long as your determinant's not 0, you're in business, you can find the inverse. I got my determinant to be 1, and that's pretty nice when you get a determinant of 1, because what that means is on the outside of your inverse when you're starting it off, you're just going to have 1 over 1. 1 over 1 is 1. When you multiply anything by 1, you get itself, which means basically I didn't have to bother with this 1. It's kind of useless. Kind of. I'm saying that loosely. Now, 4 and negative 8 switch spots. Boom. 11 and negative 3 stay where they are, but they pick up opposite sign. 11 was positive, now it's negative. 3 was negative, now it's positive. I take my inverse, I plug it into this formula. I multiply it by b. b is going to be the negative 11, 7. And from there, it's just straightforward matrix multiplication. Okay, row times column to get this row. Second row times this column to get this second row. And then simplify, do the computation. Calculators can be very helpful. However, you should be able to do all of these calculations even without a calculator. The calculator is used for efficiency, for speed, not as a crutch. And you might be in a situation, maybe even for the final, I might have a calculator, no calculator part. So you need to be able to do these calculations without a calculator. However, to save time, it's nice when you have a calculator. Because it makes things go quicker and you can get more done. And after you simplify here, hopefully you got 11, negative 5 like I did. All right, that concludes this video. I hope you found it helpful, and you're right now watching it in class with me, most of you. So if I said something that was confusing or you're not sure how I got something, please do call me over and let me clarify. All right, thanks for watching. I appreciate it. Take care. Bye-bye.